Hi all, welcome to our channel Tech Tutor for You. This is Dr. Maheshwari. Today I am going to discuss about the power calculation of amplitude modulated wave as well as the calculation of transmission efficiency of the corresponding system. Coming to the power relation of amplitude modulated wave, we should know about the final expression for AM wave. It is Vam of t is equal to Vc sin 2 pi fct plus Ma Vc by 2 cos 2 pi Fc minus Fm of t minus Ma Vc by 2 cos 2 pi Fc plus Fm of t, where Fc is the carrier frequency component, Fc minus Fm is lower sideband frequency component, Fc plus Fm is USB upper sideband frequency component. So an AM wave contains three components which are carrier, LSB and USB components. So with respect to that, the total power of AM can be expressed as Pt is equal to sum of three power components which are carrier power, USB power and LSB power. So to calculate the powers of the corresponding components, we are in need of the coefficient of the each and every component. For the carrier, it is Vc. For the LSB, it is MAVC by 2. For the USB, it is also MEVC by 2. So we have to consider only the positive value as the magnitude or the coefficient of the corresponding components. So we know that the relationship between power, voltage and resistance are P is equal to V squared by R. So V is nothing but the voltage of the corresponding signal or the amplitude or the magnitude of the corresponding signal. In the communication system, always we have to consider the V as root mean square voltage, that is VRMS, to find the accurate value of the corresponding signal. So instead of V, we have to substitute V by root 2. Firstly, we have to calculate the carrier power. So carrier power is nothing but Vc squared by R. So instead of Vc, we have to substitute. That is, instead of V, we have to put down as root mean square voltage. So Vc as Vc by root 2 the whole square divided by R. Therefore, Pc is equal to Vc squared by 2R. In the same way, the USB power is nothing but either magnitude of the USB or the voltage of USB or the coefficient of USB the whole square divided by R to be considered. The magnitude of LSB and magnitude of USB is same, which is nothing but MAVC by 2. So instead of VC, we have to substitute VC by root 2. So therefore, we will get MAVC by 2 root 2 the whole square. Simplify it, we will get PUSB is nothing but MA squared VC squared by 8R. Similarly, PLSB is magnitude of LSB square divided by R, which is nothing but MAVC by 2 root 2 the whole square. After simplification, we will get PLSB as MA squared VC squared by 8R. By adding all the power components, we will get PT is equal to VC squared by 2R plus MA squared VC squared by 8R plus MA squared VC squared by 8R. So from these three terms, taking V6 squared by 2R as common, we will get 1 plus MA squared by 4 plus MA squared by 4. Go for ordinary simplification. We will get VC squared by 2R into 1 plus MA squared by 2. So finally, we know that VC squared by 2R is nothing but PC. So the relationship between the total power and the carrier power, which is nothing but, or the final expression for total power is Pt is equal to Pc into 1 plus Ma squared by 2 for an amplitude modulator wave, where Ma is nothing but modulation index of AM wave. So coming to the current relation of the corresponding waves, the relationship between all the currents, what are all available. We know that Pt is Pc into 1 plus Ma squared by 2. So with respect to current and resistance, power is nothing but I squared R. So instead of Pt, we can substitute It squared into R. Instead of Pc, we can substitute Ic squared into R. Go for ordinary simplification, that is cancel R on both sides. So we will get It squared is equal to Ic squared into 1 plus Ma squared by 2. The final current relation of AM wave is Taking square root on both sides, we will get IT is equal to IC into root of 1 plus MA squared by 2. Coming to the efficiency of the AM system. So efficiency is denoted as eta. It is nothing but the relationship between sideband power and the total power. That is PSB by PT. PSB, which is nothing but the sum of two sideband powers, PLSB and PUSB. So eta is equal to PLSB plus PUSB and PT. We know all the values for the corresponding powers. Just go for substitution. We will get this equation. So go for ordinary simplification, taking VC squared by 2R outside from the numerator. We will get VC squared by 2R into MA squared by 4 plus MA squared by 4 divided by PC into 1 plus MA squared by 2. We know that PC is nothing but VC squared by 2R. Cancel down and simplify it. We will get the expression for eta, which is nothing but MA squared by 2 divided by 1 plus MA squared by 2. Again take an LCM and simplify it. We will get the final expression for efficiency is eta, which is equal to MA squared by 2 plus MA squared. So in terms of percent, multiply this expression with respect to 100. We will get the transmission efficiency of an AM system in terms of percentage. So finally, for the 100% modulation to be obtained, we can assume the value of modulation index of AM as 1. So lesser than, we have to always assume the modulation index as less than or equal to 1 in practical manner. Greater than, taking the value of MA as greater than 1 means that can be considered as over modulation. So here put the value of MA is equal to 1 in the equation. We will get eta is equal to 1 by 3. By means of percentage, the efficiency in terms of percent, which is nothing but we will obtain 33.33%. So the transmission efficiency of the AM system is only 33.3% efficient. The rest of the power is wasted by means of transmitting the carrier signal. Thanks for watching this video.